So I welcome you to this video lecture. So if I say something like many times addition is multiplication. Many times addition is multiplication. Can I say this? I hope many of you would have guessed what I'm trying to say. So if I have something like a plus a plus a, so can I write it as 3a, or also I can write it as 3 into a. So I can see that if I'm adding the same thing again and again, that means many times I'm adding it, then it is actually multiplication. So many times addition is multiplication. Instead of addition, if I make it many times multiplication, so let me just write it. So many times multiplication, is what it will be. So let us see what it can be. So instead of adding a plus a plus a, let me just multiply it and write a into a into a. So a into a will be what? A into a into a will be a cube. So I can say many times multiplication is exponents, or we can even write exponents as index or index. So the chapter that we are going to deal in the coming week is indices. So let me write it properly. It will be indices. INDICES, indices. So in your lower classes, you have already looked at some of the rules which will also be applicable over here as well. All of you know a to the power 0 is 1. This holds because a to the power 0 I can write it as a to the power 1 minus 1. 0 I can write it as 1 by 1. So it will be a to the power 1 divided by a to the power 1. So instead of writing 1, so let me just remove it. I can make it 1. So I can say that a to the power 0 is equal to 1. So this is one of the rule. Also one rule I have is a to the power m into a to the power n equals to a to the power m plus n. Something like if I have 2 cube, 2 square into 2 cube, I can write this one as 2 into 2 to the power 2 plus 3, that is 2 to the power 5. So this is how we can make use of this rule or formula. One more we have is a to the power m to the power n is a to the power mn. Something like if I have 2 square into cube, it is nothing but 2 into 2 to the power 2 into 3, that is 2 to the power 6. So in this way I can make use of this formula. So let me just write one more. I hope all of you are noting down all the rules that I'm writing. A to the power minus n, I can write it as 1 by a to the power n. So this is how we can note down all those formulas or the rules. So one more rule I'm going to write is a to the power m by a to the power n is nothing but a to the power m minus n. Suppose if I have a cube by a square, it will be a cube, that is a to the power 3 minus 2, that is a. So this is the way we can explain all these rules. One more last rule which is very significant is, let me just erase this first. I have a to the power m equals to a to the power n. If I have like this, and if the base are same, remember this is called as base. If you're not clear, these are called your exponents or index. Exponent or index. So if I have a to the power m equals to a to the power n, that is bases are same, then I can say m will be equal to n. Something like if I have 2 square equals to, let me just, instead of giving 2 to the power a and 2 to the power b, then I can say a is equal to b. So this was just a revision of what we have done in our lower classes. Now in your standard, so we are going to look at the cases where it will be extended to cases where index or exponent will be your rational numbers and base will be a positive real numbers. Something of this kind, this form, 2 to the power 1 by 2 or 2 to the power 1 by 3. And many of you will be very much familiar that 2 to the power half is nothing but root 2, and 2 to the power 1 by 3 will be 2 to the power cube root of 2. Similarly, if I have 2 to the power 1 by n, then I should write nth root of 2. So this is what it means whenever I am expressing the exponent in fractions or in rational numbers. This symbol that we have been using in the roots is known as radicals. So we will be discussing about this kind of problems in the classes to come. Thank you all of you. So hope to see you in the classes.